Hi guys, of course we are on board for chapter 21 now, and today we're going to be working about lesson 21.1, which is all the features on the two main kinds of solids we're going to be check on for the entire chapter. We're going to be working on pyramids and prisms, right? But before going into those two terms, I want to tell you about the three main features any solid should have. And those are faces, vertex, and edges. The face, the vertex, and the edge are three features we need to keep in mind if we want to be able to describe a solid well, all right? Think about a cube. We all know what a cube is, isn't it? We do. And so if we do have a cube, well, forgive my horrible drawing though. Let's just pretend this is a nice cube to work with. Then we're going to have three things to look at. The first one is the face. The second one is going to be the vertex. And the third is going to be the edge. Okay? So when we talk about a face, please keep this in mind, this definition in mind. A flat surface that forms part of the boundary of the solid. In other words, a face is pretty much what borders the solid. Now, since we are in 3D, the border is never going to be aligned as it used to be in the 2D shapes, right? Now it gotta be like walls. So we gotta think about faces as walls. A face can be seen as a wall that borders, and it's related to the word or to the understanding of border as we understood it in 2D shapes, all right? We're just looking at walls here though. Okay, now let's go with edges. We have edges here. This is an edge. What's an edge? An edge is nothing but the line where two faces encounter. So we know a face is like a wall, like a boundary for the solid, right? And the edge is where two faces encounter. So we're only thinking about lines now, okay? We know a face usually is a 2D shape. But then the edge is just a line. It's the line where two faces encounter. And finally, the vertex is actually a point. We can call it a corner as well, right? We can call it a corner. Those corners are the points where edges encounter. So in this corner, these two edges encounter. In this corner over here, these two edges encounter, but these two edges encounter as well, right? So we now here we're talking about a point now. Okay? And so we need to understand faces, edges, and vertices, because the proto here is going to be vertices. All right? And once we have those clear, then declassification into prisms and pyramids is going to be way easier. Because we actually need to be able to identify faces, edges, and vertices to be able to see how can we describe a pyramid or how can we describe a prism. All right? Let's go with prisms and pyramids then. If you think about pyramids and prisms, they both are solids, of course. Now, they have very specific features. I want to talk about a hexagonal prism here. How is that going to be? Well, something like this, I guess. Please, I'm not a good drawer, so please just have mercy, all right? Those pro drawers we have in the classroom. Please just be patient with me, all right? And so over here, that would be a hexagonal prism. Now, prisms have two bases. We need to keep that in mind. A base is pretty much the main face of the solid. So if you think about a base, think about it as the main face in the solid, okay? And that base usually gives the name. It does give the name to the solid. So in this case, the two bases are gonna give us the name. So if the base to the solid, it gives the name to the solid. So here I have a hexagonal prism. The bases here, of course, this is gonna be one of my bases. I know this is one base, right? And the other base gotta be underneath. So I know the other base is right here, okay? Keep in mind, in a prism, the bases are parallel. What does that mean, parallel? Well, they're just at a distance where they're never going to encounter, right? I know this base and this base over here, they will never encounter, they will never intersect somehow. So they're parallel. And so I know if I have one base up here, then the other base gotta be down here. They cannot be in the lateral faces, right? So the hexagonal prism has two bases. And because of the polygon I have on the base, I get the name of the prism. In this case, hexagonal. The other feature we need to keep in mind here, it's what is the characteristic in the lateral faces. Prisms have lateral faces. What does that mean? Well, the faces that go around the base. The lateral faces in a prism are always going to be rectangles, guys, okay? So we cannot picture anything different from that, all right? And we just need to keep in mind that if I have a base that has 6 sides, which is a hexagon, then I should have definitely 6 lateral faces, which are rectangles, hopefully with the same measures if we have our regular hexagon up here, of course, right? Think about the cylinder though. What is a cylinder? Well, the cylinder, something like this, right? The cylinder has 2 bases, but in this case the bases are circles. Now, as you remember, a circle has how many sides? Infinite. You know that. So if I have a circle with infinite sides, then how many lateral faces am I going to have? Infinite as well, right? So a cylinder is nothing but a prism. All right? It is just a prism that, yes, it does have 2 circular bases. It does have infinite rectangular lateral faces, and therefore it is a prism that has infinite faces. Just keep that in mind. So cylinder is related to prisms, always. All right? And so if we understand prisms, then we understand how a cylinder works. Now let's go and work with pyramids. I'm going to go and see how does a pyramid is described, right? I'm going to do, again, a hexagonal pyramid. And then pyramids are solids as well, of course. They're also solids. But these solids are actually different a little bit. How are they different? Well, they, first of all, only have one base. All right? So we have only one base this time. The one down here. This is my base. And again, The base gives me the name of the pyramid. So we know the base is the main face in the solid. And here, as you can tell, we're always going to have one vertex that is against the face, the main face, which is the base, right? And so there's always going to be one vertex that goes above the base. And it's parallel to the base. That means they're never going to intersect. In this case, as you can tell, the lateral faces here are going to be triangles. So we're thinking about always having triangles in a pyramid. How many triangles? Well, as many sides as the base has, of course, right? Think about the cone though. The cone has one base as well. And that one base is actually a circle, right? And again, because the circle has infinite sides, then we know we're going to have infinite lateral faces. Of course, they're all triangular, but they're going to be infinite. So in this case, the cone is also going to be related to a solid kind, which in this case is a pyramid. Cone is like a general form to see pyramids, all right? So every time you think about a cone, think about pyramids. How pyramids behave, that's the way a cone is going to behave. If you want to think about cylinder, think about how prisms behave, all right? Alrighty then. Now the last thing I want to show you, well the last two things actually, is first the net. I mean, as you can tell, you have read already the lesson, so that's not a problem, but I want to make you understand, how can we build a net? Depends. If we have to build the net for the hexagonal prism we draw before, we actually need 6 sides, right? And 6 lateral faces. So I'm just going to think about a huge rectangle, and I'm going to divide it into 6 equal smaller rectangles. 1, 2, 3, 4, 5. Okay, well this is not probably like this, and this is probably going to have to be a little bit wider like this, right? And then I just need the 2 bases. I'm going to draw one here, one over here, right? And then I'm going to draw the other one over here. Can I draw them anywhere else? Sure you can. Sure you can. The one thing you cannot do though, is to draw both up here or draw both down here. Because then they're going to, they're going to get overlapped, right? And you're gonna end up with a hole on the other side. So you need to make sure one is one on this side and the other base is on this side to get the net. This is one net. Now can I have the hexagon right here in the middle? Sure, not a problem. Or can I have this hexagon right here at the end? It's all fine, right? So nets work just like that. Now in the case of a pyramid, I probably do it differently. My idea of making a net here is actually getting the hexagon first, right? And once I get the hexagon, then I'm just gonna have triangles out of it. I'm gonna try, of course, to make the triangles as equilateral as I can, or as congruent as I can actually. Not equilateral, but congruent, right? And that could be actually the net for my hexagonal pyramid, all right? It's just one way I see it, and it's probably the easiest for me to see it. For prisms, I just make the rectangle first, and then I locate the 2 bases. And for pyramids, I locate the base first, and then I just get triangles around it, and that's it. Now, if we need to find out how many vertices, or how many edges, or how many faces does a solid have, whether it's a pyramid or a prism, how can we figure that out? Well, I know you can count, sure, and you can use the website I provided you, it's fine. But if you really want to just take a very short amount of time, then my advice is use this little formulas over here for you to be able to find out. I mean, of course, you can always count and imagine the figures in your mind. That's for sure allowed. But if we keep in mind that n is the number of sides of the polygon you're working with, then think about just like a pentagonal. Let's just think about a pentagonal prism. Something like this. Well, not easy. I know it's not easy. Probably something like this, right? I'm just gonna make it a little bit longer just to make it different to what we draw earlier. And so here we're gonna have something like this, and over here like this, and something like this, right? Of course, I could think about a little shadow over here that kind of shows me how does the back of it look, which probably makes it a little bit harder to see, right? But you can definitely just look at it without it. Whatever you want to do, it's fine. Now I need to find the total amount of vertices in this one. So if I want to find the vertices in this one, sure, I can count them, and that's fine, right? I can just count them. But how about I use the formula, 2n. So I know it's twice n, and n is a number of sides, so I know it's twice 5, which is 10, and that's it, right? Can I count them? Sure, 1, 2, 3, 4, 5, and I need to imagine, actually, the one vertex I'm not able to see, which is in the back. How about the edges? Well, I can also count them, right? And count and imagine the one I don't see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm missing actually 3 edges in the back. But how about I use the formula, 3n. So it's gonna be 3 times 5, and I should have in 15. How do I know it's 15? Well, 5 up here, 5 I should have down here, that's 10, and 5 I should have around it. So that's 15. But I can use the formula as well, right? How about the faces? Well, the faces are going to be n plus 2. Because remember, we have 2 bases and then just lateral faces around it. So it's going to be n plus 2. That is 5 plus 2. So we know we have 7 faces in this case. See? It's just that simple. So you can work it out this way. Now, if we want to do the same exercise for a pyramid, I can just think about, again, a pentagonal pyramid, okay? There you go. And so this is going to be my vertex over here, and then I'm just going to begin getting the edges to build it. Now again, the vertices, well, we know it actually makes sense if we think about 1, 2, 3, 4, 5, and the 6th that is on top of the base. But we can just go ahead and say, well, that's n plus 1, which is 5 plus 1, that's 6, right? How about the edges? Well, the edges here, again, it's the lines where the faces encount, so I need 1, 2, 3, 4, 5 here, and then 5 around. That would be 10. But I can definitely just say twice n, and that's going to be 10, right? And for the faces, well, I have 5 around because it's 1 per side in the base, and of course the base. So I know it's going to be 6 or n plus 1, which is the same 6. See? Either way, you should be able to find it. Where are these formulas very, very, very useful? When you're dealing with solids, you're not actually having a image or model, and they just have too many vertices or too many faces or too many edges, and in your mind you're just not able to actually keep everything into the account you're making. All right, but it's pretty much this, guys. I mean, if you keep this in mind, the entire lesson is going to be super easy. All right, so I'll see you later for next lesson. All right, bye.